Dear friends, in this video we are going to discuss about importance of steam nozzles, types of steam nozzles and application of steam nozzles. Steam nozzles are the important component, thermal component or thermal equipment in many applications, thermal related applications like aerospace, engines, boilers, turbines, power plants, jet engines. In many places we are finding the application of steam nozzles. The definition, if we look at the definition, the purpose of steam nozzle is to increase the velocity and reduce the pressure. When the steam is allowed to expand through the steam nozzle, the velocity is increasing tremendously. At the same time, the pressure is reduced drastically. Purpose of the steam nozzle is to control the direction characteristics of the fluid flow, especially to increase the velocity as it exits in an enclosed chamber or pipe. A nozzle is often a pipe or tube of varying cross-sectional area, and it can be used to direct or modify the flow of fluid. To convert the pressure energy and thermal energy into kinetic energy, mostly the nozzles are used to convert pressure energy into kinetic energy.
Some
Application
applications.
nozzles. Converting thermal energy to kinetic
Some
energy.
applications of a nozzle. Nozzles
Yes,
are
nozzles are used for converting.
some applications of a nozzle.
Yes,
Nozzles
application
are
of
used for
nozzles.
converting
It is used to measure.
some applications
This
of a
is another
nozzle.
application of nozzles.
Some
Here, if you look
applications
at the
of a nozzle.
cross-section areas, it is used
Nozzles
as an
are used
injectors
for
for pumping
converting
feed water to
thermal
boilers.
some applications
Here,
of a nozzle.
the application nozzles
Nozzles are used
continuation.
for
Gas turbine also we
converting
can have the
thermal
application of
energy into
nozzles. It is a device having duct of varying cross-section which converts heat energy into kinetic energy. Heat energy of steam is converted into kinetic energy of steam. We have to ensure that the loss is minimum. When the energy conversion is taking place, we have to ensure that the loss is minimum. The high temperature, pressure steam first expands in the nozzle, emanates as a high velocity fluid stream. The high velocity steam coming out of the nozzles impinges on the blades mounted on a wheel. The fluid stream suffers a loss of momentum while flowing past the blades that is absorbed by the rotating wheel, entailing the production of torque. The moving blades move as a result of the impulses of steam caused by the change of momentum and also as a result of the expansion and the acceleration of steam relative to them. It is the form of duct smoothly varying cross section area which converts heat energy into kinetic energy. So if you look at this, we can have a clear idea that fluid enters here, the converging part, throat and a diverging part. So there are three parts of a convergent divergent nozzle. The one is convergent part. This is called convergent part. This is throat. This is divergent. This portion is called convergent. That is area of cross section is reducing. Here it is constant cross section area. Here the area of cross section is increasing. So convergent, divergent. In between we have the throat. So this is called convergent divergent nozzle. Types of steam nozzles. Convergent nozzle. The area of cross section is reduced. Divergent nozzle area of cross section is increased. convergent divergent nozzle. It is a combination of both convergent and divergent nozzle. The cross area is decreases as the flow goes through this. This is convergent. Sonic flow is the flow of the flow which has the same velocity as the sound. M less than 1 becomes M equal to 1, sonic velocity. When the flow is subsonic, that is M is less than 1, velocity of fluid at the exit of the nozzle is less than the local velocity of sound. Divergent nozzle. This is called convergent to divergent nozzle. Cross section of nozzle first decreases from its entrance to throat and then increases from its throat to exit. The section where the cross section area is minimum is called throat. The convergent portion, the steam enters the nozzle with a high pressure but the negligible velocity. Thus, there is a drop in steam pressure with a rise in its velocity. So, if you look at this, here pressure is high, velocity is less, whereas here the velocity is considerably increased, pressure is reduced. There is a drop in steam pressure at this point, drop in steam pressure, and at the same time increase in velocity. There is also drop in enthalpy or total heat of the steam when it passes through the nozzle. The drop in heat is not utilized for extra work, but it is converted into kinetic energy. The drop in heat energy, that is enthalpy, is used to convert into kinetic energy. The turbine only the loss in the enthalpy is converted into mechanical work. The turbine it is mechanical work, in the nozzle it is kinetic energy. The loss in heat, that is enthalpy loss, is converted into kinetic energy. The second portion, the divergent portion, there is a further drop in steam pressure and further increase in velocity. Here the pressure drops, whereas velocity increases at this point. At the exit of the convergent divergent nozzle, velocity increases, pressure is dropped considerably. Enthalpy drop is there, which is converted into kinetic energy as in the case of nozzle. The convergent divergent nozzle is used for convert subsonic flow into supersonic flow. So high pressure, low velocity. This is high pressure, low velocity. Here low pressure, high velocity. This is concept of convergent divergent nozzle. Here Mach number 1. Here subsonic, here supersonic. So clearly understand this. High pressure in the convergent portion the subsonic. The divergent portion supersonic. The throat Mach number equal to 1 sonic. Subsonic, sonic and supersonic. Mach number equal to 1 means subsonic. Less than 1 means subsonic. More than 1 means supersonic. This is called convergent divergent nozzle. In many places, many steam turbines, we are having only convergent divergent nozzles. The pressure at which steam leaves the nozzle is known as back pressure. That is important definition we have to understand. The pressure at which the steam leaves the nozzle is called back pressure. No heat is supplied or ejected by the steam during the flow through the nozzle. That heat is neither supplied nor rejected. The heat supply is constant. No heat supply. Naturally, there is no heat supply in the case of nozzle. It is considered as isentropic flow and the corresponding expansion is considered as isentropic expansion. The flow through the nozzle is classified as isentropic. So the pressure at which the steam leaves the nozzle is called back pressure. So at this point the pressure is called back pressure. This is called back pressure. Okay. So in this video we have seen different types of nozzles and application of nozzles. Thank you for watching this video. Thank you.